Good morning, everybody. I congratulate you on admission to a medical university, namely to our pediatric university, and welcome to our Department of Medical Physics, where we will study the processes that occur in our body, namely the physical foundations of these processes. And now I must tell you some words about our course. And our course at the Department of Medical Physics divided in two parts. The first part, the small first part, information support of medicine, and the second big part is medical physics. And at the end of this course, you will have a final grade. Especially, you must know about it, you will have a final grade. And some words of the course, information support of medicine. What does it include? This course is short and practical, especially practical. It includes the performance of two estimated works, estimated or settlement works. The first settlement or estimated work is the analysis of data by various methods of mathematical statistics. This settlement work is quite large. We will perform it with two lessons, according to the results of which you will learn how to use some statistical criteria to process small groups of data. Only small groups of data, and this course you will necessary on other departments to analyze the some data. Further, in the third lesson, we will carry out with you the second estimated or settlement work. The name of this work is Elements of Correlation and Regression Analysis. In this calculation work, we will check with you the relationship between two related quantities. And the data for performing design work will be given to you in practical classes. And the final lesson for this course is a test to test your knowledge of this course, which includes 40 multiple choice questions. The final test for this course will be in writing. Especially, don't forget about it, it will be in writing, like as in Russian language, full answer you must write, and in the form of a detailed answer to one selected question on the ticket. But this is not soon for us. We will begin our classes at the department with another course, medical physics. It includes two large parts: laboratory works, the 6 laboratory works, and practical exercises in the form of discussion and analysis of new topics in our course. And now, in total, we will carry out 6 laboratory works. What laboratory works will be in our department? The first laboratory work is determination of hearing thresholds using an audiometer. You will try to determine the acuity of your hearing during this laboratory work. In our department, we have the audiometer, and you will try to check your hearing, really. And the second laboratory work, study of hemodynamic parameters. During this laboratory work, you will measure blood pressure by the Korotkov method at rest and after some exercises in our department or at your homes. As well as with the help of pulse oximeters, you will simultaneously measure the oxygen content in your blood. And based on the results of the work, you will conduct a comparative analysis of your data and determine the time of complete recovery of your cardiovascular system. The third laboratory work, simulation or modeling the erythrocyte sedimentation process. and determination of the viscosity of liquid. During this laboratory work, you will simulate the process of erythrocyte sedimentation in the blood in a glass capillary like this, as doctors' laboratory assistants do when they determine the sedimentation rate of our erythrocytes. When we go to laboratory and test our and want to test our blood. And for example, when we want to know how much erythrocyte, how much leukocytes, yeah, or have we inflammation, yeah, in our organism, for example. Based on the results of this work, you will have to determine the viscosity of the liquid that will be provided to you for laboratory work. The fourth fundamentals of electrocardiography and the construction of the average electrical axis of the heart. Really, when performing this work, you will each other shot an electrocardiogram in 3 leads from the limbs. Only from the limbs, from our legs and our heads. Then you will analyze the teeth and intervals on the obtained leads and, based on these results, build the Eindhoven triangle to determine the average electrical axis of the heart. But don't afraid, please. Your teachers will always help you with this laboratory work, and they will try to explain you how you can analyze the teeth and intervals on electrocardiography, and how can we demonstrate it on laboratory work, demonstrated, and understanding, and some understanding about this process in our organism. The fifth laboratory work is determination of the characteristics of laser radiation. It based on the results of this work, you will determine the wavelength of the laser with which you will work in the lesson. To complete this work, you will count a lot, but you shouldn't be afraid, and your teachers will always help you again too. Yeah, don't forget, don't afraid it, please. And the last laboratory work will be is about optical system of the eye. During this very interesting work, you will try to determine your visual acuity right in the physics class, and you will learn more about this work in the classroom. It will be the secret for you. Some secret information. And let's continue. I must say you about practical lessons. Yeah, I said later. And what practical lessons will be on our department? 5 big parts. Will be bioacoustics, hemodynamics, optics, ionizing radiation, and medical electronics. We will analyze all these sections in detail in our practical lessons, and you will also listen to new information in these lectures. Not only practice lessons, in lectures too. And now I must now we let's go directly to the topic of our today lecture. Today theme of our lecture is bioacoustics, the first part of bioacoustics. And to begin with, we must figure out what bioacoustics and acoustics are in general. Let's start with the simpler thing. Acoustics is a branch of physics that deals with the study of all mechanical waves in gases, liquids, and solids, including topics such as vibration or oscillation, sound, ultrasound, infrasound. Everything seems to be logical and understandable. But now we are faced with another question. What is bioacoustics? Acoustics, we said. What is a bioacoustics? I think you already have an answer to this, because you will say that from Greek language bioacoustics, the first part is bio. What is about bio? This is life, and which means bioacoustics is a science that connects biology and physics. And you are absolutely right. Bioacoustics is an interdisciplinary science that combines biology, medicine, and acoustics, especially medicine. And on our lectures and on our practical lessons, we will see this combination and understand this combination. And now, bioacoustics study, we must start from the basics. And if we compare the study of this section with building of house, for example, then first we must lay the foundation of house, the base. And our foundation will be oscillations. Consider what oscillation is. Oscillation refers to any periodic motion that moves at a distance around an equilibrium position and repeats over and over a period of time. And consider the examples of oscillations in the figures on this slide. From the left side, oscillation of the spring, up and down, up and down, up and down. And on the right is a mathematical pendulum, where oscillations swing from the right to left or side by side. From the right to left, right, left, through the zero position. Consider the characteristics of the oscillations. We should tell about it. Let's start with the basics. This is the amplitude of the oscillations. I think you know about it. What is about amplitude? Amplitude is the maximum displacement from the equilibrium position. Let's look at the figure on the left, on this picture. We estimate the amplitude along the ordinate, denote it by xm. You can see it. Further, the period of fluctuations denoted by a large letter T. Period, what is about period? Is the time when one complete oscillation occurs. It is a complete hesitation. This is a very important point. Let's look at the picture on the right part. And you have a period as the distance between two peaks on this chart. For example, this is period full oscillation. Or from this point, on the one hand, through the zero position, on the other hand, and come to zero position again. And it will be the full one oscillation or full one vibration too, and the time of period from this point to this point will be. The next physical characteristic of oscillation is frequency, denoted by a small letter f. You know this letter. And oscillation frequency is the number of oscillations per unit of time. That is, in fact, this is the inverse of the period. Let's look at the formula by which we can calculate the oscillation frequency, knowing the oscillation period. By the way, on the contrary, the formula also works. We can calculate the period of oscillation knowing their frequency. Opposite part, yeah? T is 1 divided by small f. And system international units of frequency is Hertz, or 1 divided by second. The next characteristic of oscillations or vibrations is the angular frequency. Angular frequency denoted by the letter omega. This letter omega, not W. This letter is omega, Greek letter. Angular frequency is the number of oscillation in 2 pi seconds. In 2 pi seconds. It is a measure of a frequency of a rotational or vibrational motion. Let's consider the formula for calculating on this formula. Please note that we can calculate the angular frequency in two ways. Through the frequency f, if we multiply 2 pi on f, or through the oscillation period t, if we 2 pi divide by t. And system international units of angular frequency is radian divided by second. Don't forget about it. Radian divided by second. Now, we have to talk about some classification of oscillations. Let's consider the first classification. We start from the first simple classification. Oscillations may be harmonic and non-harmonics, just like a pair. Harmonic oscillations are oscillations that occur according to the law of sine or cosine. Sine or cosine. On the left part, you can see the graph of the function and the function itself. For example, this is a sine, yeah, and you have a function of this graph. What is about non-harmonic oscillations? Everything is simple. There are all other oscillations that don't occur according to the law of sine or cosine. In the figure on the right part, you can see the examples of graphs of the functions of such oscillations. For example, maybe this, yeah, and this, don't forget, please, connection between time and displacement, like as in harmonic oscillation, time and displacement. We must also consider with you damped oscillations. Guys, all the oscillations in our surrounding life are damped, really. Damped oscillations are free oscillations of a mechanical system in the presence of frictional forces or resistance forces of the medium. In any real oscillatory system, there are always frictional forces or resistance forces. Without them, you and I would not be able to live on our planet without resistance. Resistance is the main force in our life. Consider free or natural damped oscillations. Since the oscillations are free, it means that the system being driven out of equilibrium position by external forces or having received an initial impulse, initial energy. Due to external forces, is subsequently left to itself and is under the influence of only a quasi-elastic force and a friction force or the resistant force of medium. We know that the action of these forces leads to a decrease in the mechanical energy of system. If we don't replenish the loss of this energy from outside due to work of external forces, then the oscillations will fade. In this case, mechanical energy is converted into heat energy. You can see the examples of these damped oscillations on the pictures. You can see that the displacement is low and low, like as in this example too, in this picture. Let's continue. Consider the next type of oscillation, a new type of oscillation, are forced oscillations or driven oscillations. I think you heard about it. We said earlier, if there is no external one, then the system will oscillate with its own frequency, free oscillations. But we have already said earlier that there are always friction and resistance forces in oscillatory system, which lead to damping of oscillations. In order to excite undamped oscillations in the system, it is necessary to compensate for the energy losses caused by friction and resistance of the medium. Such compensation can be made due to force external to the oscillatory system. The energy of the system is replenished due to the work of an external force. Oscillations caused by an external periodic driving force with a frequency different from the natural frequency are called forced oscillations. You can see the picture. Right picture, not right picture. See, please, on the blue parts. Yeah, on the blue parts. Don't forget about, please. Next. Next is about the resonance, yeah? Some words about the resonance. Forced oscillations considered earlier arise when an external or outside force acts on the body with a certain frequency. It is very important that this external force acts on the body at the right time and in the right place. Exactly, it is who replenished the loss of energy and increases it with the body's own oscillations. When the frequency of the action of the force approaches the natural frequency of the system, then the amplitude of the oscillations will increase. And at some point, resonance will be achieved. This is when the natural frequency of system coincides with the frequency of the driving force. There are many examples of resonance in our life, and which you have already heard about. This is a well-known children's swing, for example. Children's swing. You can see this picture on the right part of this slide, but on the left slide, you can see the amplitude, amplitudes of the oscillations, and you can see the example of resonance. Now, having built the foundation of our house, we must begin to build the walls. The walls in our situation will be waves. And a wave is already a more complex process than the oscillation. Let's consider. Firstly, a wave is a disturbance passing through a medium. And secondly, a wave can also be called a disturbance or change that gradually transfers energy from point to point in the medium. And in order to create a wave, we need two participants. This is the source of oscillations and the environment. On the picture, you can see the examples of wave and how wave can spread through the medium. The energy can spread through the medium because we say about especially mechanic waves. There are many types of waves. In our life. Firstly, we must say about mechanic waves. Because mechanic waves, the main waves which we can know about our organism. Let's continue. We must also learn with you that the particles in the medium don't move with the wave, but create oscillations. So that wave can move from one place to another. One place to another. You can see that on this picture how the compression and refraction spreads through the medium, and what is about particles? Particles how can drive, and wave spreads through this medium. And what kind of waves are there? Let's consider the classification. First, there are longitudinal waves. Longitudinal waves are those in which the oscillations of the particles go in the same direction as the direction of the wave motion. The simplest example of longitudinal waves is sound wave, really. There are also transverse waves. Transverse waves are called waves in which the oscillation of particles are perpendicular to the direction of wave motion. An example of such waves is a wave in a string of guitar. Wavelength is one of the main physical characteristics of waves. About waves, physical characteristics about waves. Firstly, we must say about wavelength. What is about wavelength? This is a distance that a wave travels in a time equal to a period. Below you can see the formula for calculating the wavelength through the period, velocity and frequency. System international units of wavelength is meter, don't forget about it. We discussed the foundation of oscillations. This is oscillation. Foundation is oscillations and walls are waves. Now we have to move on and try to install windows in our house. We move on to the next step, to sound. We all have a familiar, well-known and beloved sound. Sound or sound waves are longitudinal waves that can be heard when they reach the human ear, our ears. Consider the drawing on this picture. We see several types of sound highlighted in red. Let's start with the sound which has a lowest frequency, up to 16 Hz. First part. This is infrasound. Our ear is not able to hear infrasound. Next comes the sound which has a frequency from 16 Hz to 20,000 Hz. or 20 kHz. This is our auditory frequency range. That is, there are all the sounds that a person's ear hears. For example, our voice, my voice, your voices, music on our phone, noise on the street, and other sounds which we can hear. Well, the sound that has the highest frequency is ultrasound. Its frequency ranges from 20 kHz or 20,000 Hz and above this part, ultrasound. Our ear is not able to hear this type of sound too, but you and I know that ultrasound is widely used in medicine. And how can we use ultrasound in medicine? We will talk later on our next lesson. Now, we must say about sound speed in solids and liquids. Let's look at some of physical characteristics of sound waves. There are more media around us: air, various liquids, and also solids. These media have a different material stiffness factors that can affect the speed of propagation of sound waves. The stiffness of material is its resistance to compression, also known as bulk modulus B. The harder the material, the more difficult it is to compress it, which means that the sound wave can travel faster. Increasing the density of the material has the opposite effect. The pressure pulse of the sound wave must accelerate the substance first forward and then backward, since it moves with a denser substance. This acceleration is slower. This relationship is well reflected in the formula which is highlighted on the slide, on this part. Don't forget the biggest velocity of sound in solid materials. For example, the sound velocity in bones are, you can see, and the velocity of sound in water, you can see too. And as for speed of sound waves in gases, it depends on the temperature of the gas and on the characteristic of the gas, such as molar mass. Yeah, different gases have different molar mass. I think you know this. As the temperature rises, the thermal motion of the molecules increases, which allows the pressure pulse to propagate faster. This relationship is well reflected in the formula, which is highlighted on the slide too. You can see. When gamma is Poisson ratio, R is universal gas constant. I see you know this number. T is temperature not period, this is a temperature. And big M is molar mass. Don't forget about root. And I think all of you know that velocity of sound in air is 340 meter per second. 340 meter per second. As for the speed of sound waves, we said about it, and now we understand with you that a sound wave is a mechanical wave that carries some energy and connects on surrounding objects, which means that it can exert some sound pressure. Sound pressure is the difference between the instantaneous pressure at the point where the sound wave is present and the static pressure of the medium. This relationship is reflected by the formula on the slide. You can see this formula, where P0 is the local ambient pressure and P is the sound pressure deviation. If we summarize it, we can answer a question: how much is total sound pressure will be? The intensity of sound. Next physical characteristic is the intensity of sound. The word intensive in Russian means strong, powerful, and which means that we can also say about a wave that it is strong and powerful. But what does this mean? What does intensity mean for a wave? Wave intensity is the amount of power P per unit area A or square. Yeah. You can see the formula for calculation on this slide. Intensity letter is big I. If we divide the power by A area, we can calculate this intensity of sound. The system international units of intensity will be watt divided by meter square. Don't forget about it. Be careful. Watts divided by meter square. And the intensity of sound is also a physical characteristic that we must analyze in detail and associate with our organ of hearing, the ear. The hearing threshold at 1 kHz is 10 in the power minus 12 watt divided by meter square. During normal common conversation in a room, the sound power is 10 in the power minus 6 watts divided by meter square. The threshold at which we feel pain, we can feel pain in our ears is 10 watts divided by meter square. But if we pay attention to the values, it becomes clear that it is not very convenient to operate with numbers, with these powers. It is not comfortable for us. To facilitate the recording of differences between sound intensities and to provide a means of accurately describing the perceived loudness of sounds, the decibel scale has been created. Decibel scale has been created. Some words about this decibel scale. Decibel scale is a logarithmic scale in which 0 decibel has been set equal to the threshold of hearing, the minimum sound we hear, minimum sound. All other decibel levels were measured relative to the I0 reference point using the formula. You can see this formula. E level of intensity is 10 multiplied on logarithm I divided by I0. This is the Weber-Fechner law. This formula is the Weber-Fechner law. What is about this law? This law refers to human perception and more specifically to the relationship between an actual change in a physical stimulus and a perceived change. This includes stimuli for our senses: sight, hearing, taste, touch, and smell. If the stimulus change exponentially or multiplied by a fixed coefficient, the corresponding perception changes in an arithmetic progression or an additive constant amounts. You can see this is the explanation about Weber-Fechner law. Weber-Fechner law. Another, you can see the table. You can see the table characteristics between different sounds, characteristics of different sounds. For example, maybe rock concert, you can see 150 decibels, or passenger's car, louder at 10 meters, 80 decibels, and other sounds, different sounds. You can see this table. And read some words about it on this table and compare the numbers. Compare the numbers of different sounds. Another physical characteristic of sound is the acoustic spectrum. The sound spectrum reflects the different frequencies present in the sound. The acoustic spectrum of a tone is the collection of its frequencies with an indication of their relative intensities or amplitudes. The lowest frequency in the spectrum, f, small f, corresponds to the fundamental tone, and the rest of the frequencies are called overtones or harmonics. Overtones have frequencies that are multiples of the fundamental frequency: 2f, 3f, 4f, and other. A complex sound can be decomposed into simple sounds. You can see on this picture, on pictures in this slide, the examples of acoustic spectrum with the different colors. Especially this is the colors of music, maybe colors of sound, acoustic spectrum. As I said earlier, the minimum frequency in the spectrum is called the pitch, and the overtone is any frequency that exceeds the fundamental frequency of sound. Harmonics, on the other hand, are pure tones represented by sine waves, in which the frequency of each sound is an integer multiple of the fundamental frequency. Fundamental frequency. You can see this is the definitions about what is about overtone, harmonic, and fundamental tone. Fundamental tone. We must now begin to consider the psychophysical characteristics. Early characteristics was a physical characteristics. These physical characteristics is the same for us. But what is about psychophysical characteristics? What does it mean? There are these characteristics that are directly related to our sensation, which means that for each of us, they will be essentially individual. Let's start with the pitch of sound. Pitch of sound. The sensation of frequency is commonly referred to as pitch. Everything is simple here. A high-pitched sound corresponds to a high-frequency sound wave, and a low-pitched sound corresponds to a low-frequency sound wave. In the case of a complex sound, the pitch is determined by the frequency of the main tone, or fundamental tone. Next characteristic, psychophysical characteristic, is loudness. Beautiful word, loudness. Loudness is the subjective perception of sound intensity and sound pressure. The volume of the sound increases as the amplitude of the sound wave increases, but a specific change in amplitude is not necessarily perceived as a proportional change in loudness. This is because the frequency of sound affects our perception of loudness. On this slide, you see the task. On this slide, you see the task. This is your homework. This will be your homework, the solution of which we will be asked by the teachers in a practical lesson. Your teachers will ask you about this task. Be careful with the definition of the sound volume. You must answer on question. What sound is more loud? Sound A, with the characteristics of frequency, this line, and level of intensity and intensity of sound. Sound A or sound B is more loud, and you must say on this answer why. Why? This question will be your homework, and your teachers will ask you about this problem, about this task on practice lesson. Be careful, please, and don't forget about it, please. Let's continue. And the last psychophysical characteristic of sound, which we will talk about, is timbre. Timbre describes the quality or a character of a sound or voice, tone color. The timbre of a sound depends on its waveform, which depends on the number of overtones or harmonic present, their frequencies and their relative intensity. Now, let's summarize all the information we heard today on the characteristics of sounds. The physical characteristics of sound are frequency, physical or objective as a name, objective characteristic. Frequency, pressure, intensity, wavelength, speed of sound, and acoustic spectrum. About psychophysical or subjective characteristics are pitch of sound, loudness, and timbre. So let's consider the mutual correspondence of this characteristic. We said earlier that the pitch of sound and loudness of a sound are related to the frequency of the sound wave. It connects with frequency, and pitch and loudness depends on frequency. But see, please, loudness depends not only frequency. It depends on sound pressure and sound intensity. Don't forget about it. These words will help to you to decide this home task. Don't forget about this. And the intensity, yes, I said about intensity and pressure. And last comparing, is about acoustic spectrum and timbre. Acoustic spectrum is inherently related to the timbre. Don't forget about it. I said that acoustic spectrum is the color of sound. Students, timbre is the color of sound too. We know that different musical instruments has a different colors. Especially if we say about piano, guitar, or different tubes. We know that this is a piano, this is a guitar, this is a tube, or other instruments. This is the colors, timbre of instrument. And we know that different tubes have a different timbre. Low timbre, high timbre, like as our voice too. Woman's voice or man's voice, we know about it, and please don't forget about it, especially about timbre. Thank you for your attention.